In this video, I will run structure model in SmartPLS 4 by using covariance-based SEM technique. First, I click on New Project, and then I type the name, Structure Regression Model, and then I click on Create button. After that, I click on Import Data File. I will search my data file. Here is my data file. I select and click on Open button. Then I click on Import button. My data file is loaded in SmartPLS 4. I click on back arrow and then I click on create model. Here I select CB SEM. As you know, SmartPLS 4 is most popular in PLS-SEM based technique, meaning variance-based SEM technique. However, it is added covariance-based SEM technique by the SmartPLS norm. So you can apply covariance-based technique by using SmartPLS 4. Before adding this technique, we usually apply more software to run the covariance-based SEM technique. So here I select CBSEM and then I type my model name, structural regression model, and then I click on save button. Here I have 4 variables in which 3 variables are independent and 1 is dependent variable. And these 4 variables contain 12 indicators. My first variable is attitude, which contains 3 indicators, 81, 82, 83. I select, drag and drop. Here I can change the name, that is attitude, and then I enter. Second variable is subjective norms. I select, drag and drop and enter. Third one is perceived behavior control. I select, drag and drop, enter. Then my dependent variable is behavior intention. I select, drag and drop, enter. Then I rearrange my variable. First is attitude. Second is subjective norms. Third is perceived behavior control. And my dependent variable is BI. So here I rearrange my variable, attitude, subjective norms, and perceived behavior control. And my dependent variable is behavior intention. So I connect these variables. Here I connect attitude to BI, subjective norms to BI, perceived behavior control to BI. Since I'm using covariance-based SEM technique, so I need to draw covariances between independent variables. So I click here on double-headed arrow and draw covariances between independent variables. To run the structure model, I click on calculate button and then I click on CBSEM algorithm, covariance-based SEM algorithm. And you can see here, this algorithm is in its beta stage. As you know, before adding covariance-based SEM technique in SmartPLS 4, we usually apply a more software and other software that can run covariance-based SEM technique. So here I click on start calculation to run the model. And you can see the result. I click here on final result and then path coefficient. I click here path coefficient and you can see here beta values and p values. So attitude and perceived behavior controls are significant because p value is less than 0.05 and subjective norms is not significant because its p value is greater than 0.05. And if you want to check model fit indices, you can see here chi-square divided by degree of freedom 1.174, which is satisfactory because it's less than 3, and RMC is also fine because it's less than 5%, and you can see here GFI, AGFI, and TLI, CFI, they all are greater than 0.90, which are satisfactory. So this model is satisfactory. And if you want to check R square, that is 38.9%. And if you want to check the construct liability and validity, you can click here on construct liability and validity. All values are fine except BI, behavior intention. Because if you see here, Cronbach alpha and composite liability, all are greater than 0.7, because 0.7 is threshold. 0.7 is criteria to check the reliability or consistency of the measurement. So all are fine except BI. And if you want to check the conversion validity, that is AVE, average variance accepted, its criteria is 0.5. So all values are greater than 0.5 except BI. BI is less than 0.5. So if you want to see the discriminant validity, you can click here on discriminant validity. There are two popular criteria. One is Funnel-Occur and the second one is HTMT. If I click on Funnel-Occur criteria, so you can see here diagonal values. These are square root of the average variance extracted, and off diagonal values are intercorrelation between the constructor. So here you can see diagonal value is greater than the off diagonal values. It means discriminability is established. And if you want to check discriminability through HTMT, you can click here and you can see all values are less than 0.90. So you can say discriminability is fine. Okay, thank you for watching. Please subscribe to my channel.